All right, everyone. Time for our next learning target here for our graphing linear inequalities unit. Yesterday, we focused a lot about graphing inequalities in slope-intercept form when it looks like y equals mx plus b. We've reviewed graphing lines in standard form. Today, we're going to focus on graphing those inequalities in standard form. So in our first example here, we have 3x plus 5y is greater than or equal to 15. Now, when I take a look at my coefficients of 3 and 5, remember coefficients are the numbers in front of the variables, 3 and 5 are both factors of 15. So in terms of, do I want to rewrite this equation, or do I want to find the x and y intercepts, I can find the x and y intercepts fairly easily here because 3 and 5 are both factors of 15. So if I'm going to find my x and y intercepts, I don't need to worry about the inequality. I'm just finding the specific points. So the first thing I'm going to do is plug in a 0 for x, because that will allow me to find my y-intercept. So that cancels out. 3 times 0 is 0. So basically we're just covering up that 3x. 5y is equal to 15, so I know that y is equal to positive 3. I can put a point right here on the y-axis. And then I have 3x plus 5 times 0 is equal to 15. So I'm putting in a 0 for y, because any point that has a y value of 0 has to be on the x-axis. So I'm just canceling out that y variable, creating a one-variable equation. 3x is equal to 15, so x must be equal to 5 because 3 times 5 is 15. Now I can plot a point on the x-axis at 5. So I got the point 5, 0, because I plugged in a 0 for y, and I had the point 0, 3. Now, when I take a look at my inequality, it was 3x plus 5y is greater than or equal to 15. Remember, greater than or equal to, we use a solid line. So 3x plus 5y is greater than or equal to 15. Greater than or equal to tells me a solid line. Now, the other day when it was in slope-intercept form, it was easy to just decide whether we shaded above or below because we only had our y on one side of the equation, so we just had to decide greater than or less than. This is in standard form where I have my x and y on the same side. So the next thing I'm going to do here is just check a point. If I pick any point above or below the line and it's a solution, I'm going to shade on that side of the line. If that point is not a solution, I shade on the opposite side of the line. So I'm going to try the point 0, 0. So if I plug in, that would be this point right here. That would be our origin. If I substitute in a 0 for x and a 0 for y, I want to see if that's going to be greater than or equal to 15. Well, I get 0 on the left side, so 0 is not greater than or equal to 15. That's false. That means this point is not a solution. So where are all the points that are solutions? On the opposite side of our line here. So I shade above. We think about picking any point here. So let's say I picked the point, let's pick this point here, 3, 2. If I plug in a 3 for x and a 2 for y, that would give me 9 plus 10, which is greater than or equal to 15, which would be a solution. So that's why I shaded above that line. Now, in our next example, you're going to see that we have 2x minus 3y is less than 9. Now, when I look at my coefficients, 3 goes into 9, but 2 does not. So I'm going to rewrite this equation in slope-intercept form. Remember, you can always choose this method. I'm going to take away 2x from both sides first. Negative 3y is less than negative 2x plus 9. Because I'm not solving for the x and y intercepts, it's important that I keep that inequality sign here as we rewrite it. Don't accidentally slide an equal sign in there. Remember, we want a positive y when we're putting it in slope-intercept form. So I divide everything by negative 3. This gives me a positive y. Don't forget, if we're working with an inequality and you multiply or divide by a negative number, we got to flip that inequality sign. Negative 2 over negative 3x Well, negative divided by a negative is positive, and then 9 divided by a negative 3 is a negative 3. So now I have a y-intercept at negative 3 and a rate of change of up 2 and 3 to the right because it's positive 2 over 3. Now when I take a look at our inequality was less than. Remember, less than or greater than are always dashed lines. The points on the line are not solutions. So we would have to exclude all of those points. Now, it's not in standard form, so I don't have to check a point. I know that y is greater than. Well, if you start on your line, where are all the bigger y values? They would be located above the line. So we would shade above for this inequality. Now, this is the video that you are watching here on Wednesday. Remember, it is your asynchronous time and that you are able to come in and get help and ask questions during our class meeting time here on Wednesday. You have a PDF to work on. It is located in the Unit 8 outline under Wednesday for graphing linear inequalities in standard form.